Right. Hello, everyone. So, my name is Jarppe. I'm a programmer at Metosin, and I'm here today to tell you about the IoT, and namely how you could use Clojure to program your IoT things, should you choose to do so. I'm looking at Malcolm. Was it correct pronunciation? No, Malcolm. Okay. Anyway. So, yeah, like Tommy said, this is actually my second time that I'm giving a speech in Clojure. This is really great. First one was like 2 or 3 years ago, or maybe 4. Anyway, it was. I remember getting into the stage and on the podium. It was not, of course, this venue. It was the smaller one close by, and I came to the podium and looked up, and I realized that there was like 100 people there. And I was amazed that, wait, when did this happen? This is like a real conference with the real people. How did this happen? And I'm here with a toy helicopter. So this is awkward. So, and look at you now. There's like 300 of us. It's amazing. So this is even more realer conference. Again, looking for Malcolm. Not a word? No? Okay. So, things have clearly improved a lot on this side. On this side, however, I'm today here with a toy computer with a blinking light. They'll never let me come here again. Anyway, best make best out of this one. So the IoT, what we are talking about. Here's some random shit I googled up yesterday. They say that by 2020, there will be 24 billion IoT devices connected to the internet, says Business Insider. Another one, they say that IoT has an economic impact between 3.9 to 11.1 trillion dollars by the year 2025. Now, I'm not an economist, but and I'm certainly not familiar with the trillion. It doesn't come up often with my personal finances, but even I know that that's a lot of money involved. One more. They say that 92.7% of programmers implement their IoT solutions in Clojure by the year 2017. This was by some random dude from Finland. Now, obviously, okay, I didn't Google up this. I made this up. But I secretly hope that we put these slides on the internet and someone else will Google and find it and take it as a fact. So here's hoping. So, okay, so actually the best explanation of what IoT is that I've heard, I think, is that they say that IoT is when you program with the real world devices. So it's when your application interact with your home lights, for example, or your refrigerator, or your cars, planes, automobiles, elevators, whatnot. So then we are talking about IoT. And of course, the term IoT is brand new, right? So the IoT is a very new thing. Well, I just could not stop myself. I just had to bring this up. What you see here, I don't know if you can see back there, but it actually says here, this is from like 2003. Well, the picture is not from the picture is from yesterday. I took it yesterday, but the device that I'm holding there in our office, that's from like 2003. The thing is that and if you see if you have a very good eyesight, you can see that it says Nokia in it. So what happened was that in 1994, I was freshly graduated and I went to work for Nokia. At that time, Nokia's best-selling product were rubber boots. Really, but they were very good boots, yeah. And there were some very clever and smart engineers working for Nokia. I was not one of them, but these clever engineers, they were implementing new stuff and inventing new stuff, and they were, dragging the whole company into the modern era of modern technology, kicking and screaming, and they wanted to make mobile phones and mobile networks. So in the unit that I was working with, they had this task to find out new kind of businesses that where we could utilize the same technology that these smart guys were making. So one thing that we came up was that we took the phones from the assembly line, took off all the user interface stuff like keyboards and displays, microphones, speakers, things like that, add some software and add some hardware, pack it up, and call it a device that could basically mobile phone for machines. And we were calling at that time machine to machine, or M2M for short. And fast forward to 2003, and this is the top of the line that we had. So this is actually mobile phone. So it has a GSM phone inside it. So you could make send and receive text messages from there, make data calls, GPRS, so IP over the mobile device in 2003. It had some like digital inputs and outputs, analog inputs, some serial ports, and get this Java virtual machine. Yeah, and this was really cool, really cool, and it was used in a lot of different kind of applications. For example, there's a company in Italy that makes those vending machines. You know, you put money in and you get sugar water out. And they were building these vending machines, and they used these devices. They put them inside there, write some Java code, put the Java code in there, and boom, the vending machine could report back office that I'm out of sugary waters and whatnot, and send a maintenance here. There was a very clever other usages, like it was not intentional, but it was once used in a bank robbery in South Africa, and also it was used in the other spectrum of law enforcement. It was used by FBI, but I'm not comfortable to go into details with on the record on those. But I will tell you more about when we are having some beers. Anyway, so it was a great device, and it was selling like a lot. And we just opened the U.S. markets, and it was a huge. So it was doing very well. Then we got the visit from head office. Some big shot came and told us that, yeah, I really don't understand what you're doing here, but you seem to be very enthusiastic about it. Good for you, good for you. But we big boys, we are a bit worried about that. How does this contribute to Nokia brand? That's the most important thing, Nokia brand. And okay, we came up said nothing. I mean, it's a device you put inside those other devices. There's Nokia anywhere, and said, yeah, that's what I thought. And whoosh, business, what you cut dead. They wanted to emphasize more on that kind of stuff that improve Nokia brand, and actually, in our case, get this, it was color covers. So they replaced this with color covers. Yeah. That's what happened when you let business people to do the business decisions, you know. No vision. Okay, enough about that. Let's forward about 10 years. We came to this day. So we were approached by this company called Flowrox. They manufacture these very, very big pumps and valves that are used in industry. Very harsh environments like in mining, mines and things like that. So they were wondering that if these IoT technologies could help them to improve their products and get more information about the products when they need maintenance and things like that. So we decided that we make a proof of concept of this IO solution for them. So it has this is still work going on that we are doing right now, but it has a fleet management so that we know in one place we have a database where we know what devices are where and what software should be running and where. We are using commercial components. I have here the Raspberry Pis, but these are not, we cannot use Raspberry Pis in here, but similar computers, but with a wider range of temperatures that they can withstand. Some very special 4 to 20 milliampere sensors they're using and things like that. And the whole idea is to see that if this kind of thing can be provided as a service. So this is what we are doing for them. So, Clojure in IoT, is it a good idea? So this was the question that we need to ask ourselves when we start to make this proof of concept. Why would you use Clojure? Well, first of all, I think the Java JVM is the first topic. It is hate it or load it, but it's a very robust platform to build on. And also we have a huge support from community with the different kind of Java libraries that we can use on. If you're a Clojure developer, you know that you can use anything, all Java libraries without any translation or anything. It just works out of the box. So that's definitely one big plus. Some of these devices might not have JVM, but they have a Node.js. Fine for us. We just take our Clojure code, compile it with Clojure script, and target to Node.js. Works for us. Already mentioned today, REPL. If you're a Clojure developer, you know that the REPL is really the most important part of the development today. This whole REPL-driven development. I think that's huge. And it's a big thing, even if you're building an application that you are running on your workstation. So you have your application running, and you just connect it over the REPL from your IDE, and you start working with your application interactively. It's a big thing. But imagine that if the applications that you are running is such that it cannot be run in your workstation, it has to be run in some other device remotely, then the end REPL, you just take the REPL and it works just like it would be in your machine. So it's a really, really great error. Again, checking Malcolm word, no? No, not real word, okay. So, and of course we have the dynamic features, like Markus already showed that you can take Clojure code, ship it up, and let it execute somewhere in some cloud. This is something that we also used in our fleet management. The idea is that the clients are very, very simple. When you boot it up, it doesn't know much about the world or what it should be doing, and that's a good thing because that same setup can be used in all places. And it's the fleet management job to decide that, okay, you are monitoring this kind of device, you should be monitoring this and this stuff, and it can take from the database that this is the code you should be running, throws the Clojure code to the device, and all that has to be done in device side is called eval on that string, and boom, your application is running. And of course, we get Clojure all the way. So we have a Clojure in our servers, we write our front end in Clojure, we talk to database using Clojure, we are using, by the way, Datomic. If you haven't tried it, amazing technology, try it, definitely recommend. And now, when we are making IoT devices, Clojure is the natural way, so we have the same tooling, same language, same libraries, same mindset. Really, really eases the way. So, I guess that's the enough of slides. I will show you some code. So, like I mentioned, that the applications that we write are such that it cannot be run on my machine. For example, in here I have a Raspberry Pi. I bought some simple card on it that has these lights and a buzzer and buttons, and it even has some silicon relays that you can use to drive some motors and things like that. But the thing is that it comes with the native library, with a Java wrapper, but the native library is such that I cannot run it in my Mac, of course. So what I did was that I make this simple application. Here you can see the lining and file. Okay, you cannot see all of it. Okay, so I made this very, very simple project. Give it a name. I take the end REPL, important part, and here are the Java libraries and the native libraries that go with it. Make a uber.jar out of it. Put it into this device, boot it up, and then take nREPL connection to it and start hacking it just like it would be in local. Pretty cool. Let's see how it works. I'm using, by the way, the wired connection because I have some issues with the wireless. You guys killed our wireless network. Okay, so let's see some code. So, like I said, we are making uber.jar, so here's my main function. Very simple, doesn't do anything, just avoiding AOT there. Requiring the core. Core looks like this. I'm using mount, by the way. Really liking it. There are some debate about that it's not so functional as compared to the component. Okay, I'm not such a purist. I think the mount is really works very well for me, and it's very simple to use, so using it. And it just requires like nREPL and some other stuff here. So here's the stuff that starts the native library. let's take that one away. So it has a mount state. I call it Piperella because the device name is Piperella. I guess it's a pun for umbrella, Raspberry Pi umbrella stuff. Okay, I'm not only one making these bad puns, I think. So I started it, and really there's nothing more to start than just call the constructor on this Java class called Piperella device. So what we can do with it, okay, and here's the end REPL. If you're a Clojure developer, nothing special, usual stuff here. So here's the application that or this code snippet that I started right away. So what it does, it takes the Piperella, asks for LED number 2, and says blink with 1000 milliseconds, and that's it. Then it wraps the stop function, calling the cancel on that future in the function that we can use in a stop state. And what it does, it's running here, and we can see that the LED is blinking. Cool stuff. So we can try something else. Let's see. We are here. Let's say, let's put comment in here. Let's call get LED number 0 from Piperella. Let's see what. Okay, I need a connection, of course. Here we are. I'm on connected. Good. I have script to start the tunnel. SSH tunnel. See the REPL is starting. Let's do some math. It seems to work. Can you see that? Yeah. Okay, we have a connection. Let's see what this. If I call this get LED, it seems it returns some Java object, some GPO LED component. Okay, let's see what we can do with that. There's probably something called toggle. Yeah, let's call. How do I do this at the same time? Yeah. Nobody can see this far, but okay, but if you could see it, you'd see that the red light is toggling and it's blinking. So okay, we get the connection. Let's try some more artistic stuff. There's in this device, there's a thing called buzzer. You can guess where it is going. We can say that called buzz on this B100. Let's sleep like 200 milliseconds. Rinse and repeat. These really carefully selected numbers there. Let's see if this works. No, it didn't work. Is it not? It's buzzer. Can you hear that? Now, I'm not Sam Aaron, but I think still it's pretty good. Yeah. Yeah, I can. Yeah, let's close it also. I think stop. One more. Okay. All right. So that's about that. I still have 1 minute left, so I can show you one more thing that I did that I have to be honest with you guys. There's been an application running in this venue this whole time. Actually, it's there's another Raspberry Pi over there. And the thing you see is a microphone. So I've been spying you all this time. Well, okay, I really, it's not that nothing sinister, but it has been recording the audio level in this room, and it calculates the maximum for each second, and then ships that information to the small application I have in a cloud. And this one shows we can try, say, the live feed. It's working, and we can try this. First of all, let's see. Here's the whole conference view. That what has happened this day. Okay, I didn't know the scaling because I didn't know how far you are, how sensitive the microphone is. It could use more scaling. Maybe I scale it like this way. Much better. Works that way. So I started it like 11:10, and then it's been running and recording the audio. There are some gaps. It crashed in a couple of times, but due to the network problems. But anyway, there's been running it, and here's my live feed just in time for me to say that that's about all I have. So thanks for having me, and I think it's time for questions. Thank you, guys. Thank you. Thank you. Thank you. Amazing. So, questions?
I've also considered doing ClojureScript and IoT, but my mechatronics professor, he said that even though it's more efficient to develop, the cost of the hardware is not gonna be valid. So you always want to do things in C, because then you can use cheaper processors, and in the long run, it's not valid. So how do you tackle that? Is that something that you considered?
I guess, yeah, if you are really price constrained, that might be the issue. But like these devices, this is something like 30 euros, 40 euros, and this has already quad-core, built-in Wi-Fi, and 1 gigahertz processor and things like that. You can get a cheaper one, which is a zero version, which costs like 5 euros. So I don't know. It depends, of course, if you're manufacturing millions and millions of them. Okay, then you really have to go to price constraint, and development cost is mitigated in there. But I feel that the price of these is so low that I wouldn't go there. I'm just much happier to develop with the Clojure, of course.
Have you been able to debug in production? Have you had a machine somewhere and then connected using the REPL and done something? There's a famous story from the Jet Propulsion Laboratory that built a system using Common Lisp, sent a probe to space, and on the orbit of Saturn launched a REPL and modified the code over a very slow connection. So can you do this with your system? Can you just send something into space and debug it from Emacs?
I think, yeah. Of course, this is just a proof of concept, and we can do whatever we like, and I think that we will use that once we get to with the real devices. But I have to confess that I have been using REPL in a live production systems a couple of times.
Sweet.
Just have to be very careful and know what you're doing, but that's how we pros do it. But of course, the most benefit I think is for the REPL is of course in the development. But yes, it has uses in a production too. Just be careful. Don't come to blame me. And when you say that I followed your advice, and now my customer is very angry. I accidentally the whole database. No more? Okay, thank you.